Welcome back to another math video here at Math Rocks with Mr. Cox. This video is all about polynomial functions and being able to write what the actual function is given a basic set of information, like, for instance, the x-intercepts. And what you see here in this graph is you actually see three different cubic functions, and all three of them, whether it's the red one or the blue one or the green one, all have the exact same x-intercepts. So obviously that's not enough to be able to actually know the equation for that function. So there's something more to it, and that's what this video is all about. Let's get it on. Before we go ahead and actually learn how to write polynomial equations, given the roots or the x-intercepts, let's go ahead and take a look now at this equation here. It's already been graphed for us here, and I have it in both what's called standard form and factored form. And understand that these two equations actually describe the exact same graph here. They're just written a little bit differently. And there'll be another video that actually shows how to take standard form and to turn it into factored form. Now, the beauty of factored form is this. Once you have it in what's called factored form, these three items here, or terms here in parentheses, are what we call the factors. So one of them is x minus 2, and another one would be x plus 1, and then the third one would be x minus 4. And the beauty of knowing it in factored form is, if you look here at the x-intercepts, one of them is negative 1 comma 0, another one is 2 comma 0, and another one is 4 comma 0. So I'm going to go ahead and write those right over here. So negative 1 comma 0, I've got 2 comma 0, and I've got 4 comma 0. So by knowing what the factors are, you'll notice that if I were to take the number here that would make this equal to 0, that would of course would be 2, and what do you know? That's one of the x-intercepts. If you take the number here for x that would make this equal to 0, negative 1 in this case, wow, that's another x-intercept, and then over here would be 4, so 4 comma 0. So putting it in factor form allows us to know the x-intercepts, and also once we know the x-intercepts, we also have these things called roots, or some people call them zeros. So they would be, in this case here, negative 1, 2, and 4. So in a third degree equation like this, if you can get into factored form, you can know what's called the roots or zeros and the x-intercepts once you know what the factors are. And what we're going to be doing is actually working backwards, where if we know things like the x-intercepts or the roots, how do we work backwards and actually come up with this equation? And the key to it is also this number out in front, this multiplier, which is really important because, as you saw in the introductory little piece there, that there are lots of equations that go through these x-intercepts, and to find the unique one is we have to find this multiplier. We call this the a value. So let's go ahead now and take a look at how that works. So the question we're going to be looking at now is, we have this third degree polynomial, and all that means is our highest power is going to be 3. And it does have 3 real roots at 3, negative 5, and 1, and it has a y-intercept at 0, 20, and we're going to come up with the equation. So first of all, if we know what the roots are, what we can do is we can actually start writing our equation right off the bat. So I'm going to go ahead and I'm going to make 3 sets of parentheses because we have 3 real roots here. And if one of them is 3, one of our factors, once we put this into factored form, will be x minus 3, because that 3 makes this equation equal to 0. Over here, if x is negative 5, this factor is going to be x plus 5. And if our other root is x equals 1, we're going to have x minus 1 here. So that it almost gets us to what our equation is going to be. And you'll notice here there's one other piece of information we haven't used yet. It's the y-intercept in this case, and it's 0, 20. And we're about to use that right now. So we know now basically almost the entire equation, and all we really need is this multiplier number that makes it the unique graph that goes through these 3 factors, or x-intercepts in this case here. So to do that, we're going to use this point up here. So I'm going to go ahead now, and obviously you know that the first coordinate is the x, and you know the second is the y. So we can use this point to actually remember that f of x is really y, and we can replace every single y in this equation with 20 and every single x with 0. So watch this. I'm going to replace this y with 20. So I get 20 equals a. I know x is 0, so I'm going to say 0 minus 3. I'm going to say 0 plus 5 when I replace the x with 0 there, and then we have 0 minus 1. Then I'm going to go ahead and simplify all this. So I have 20 equals a. This becomes negative 3. This next set of parentheses becomes 5. And this next one is negative 1. When I multiply negative 3 times 5 times negative 1, I get a positive 15. So I get 20 equals 15a. And then all I need to do to solve for a is divide by 15 on both sides. And if I reduce this, they're both divisible by 5, so I get 4/3 equals a. So therefore, our final equation is going to be f of x equals our a value, and then we're going to have x minus 3 as one parentheses, x plus 5 is the next, and then the final one will be x minus 1. So that's how it works. It's all about changing the roots into these factors and then finding the a value and then just plugging that in. As always, if you like what you see, please like, comment, or subscribe. Thank you, and now back to part 2. All right, so here's one more example. In this case here, we actually have a 4th degree polynomial, and we have the x-intercepts this time, not the roots, and we also know it passes through this point, which isn't necessarily the y-intercept, but it doesn't really matter. So now that we know what the x-intercepts are, we can go ahead and start writing our equation. So we'll say f of x equals a. That's going to be the multiplier that we're going to figure out later. And we're going to have 4 sets of parentheses because we have 4 different x-intercepts. So if one of them is 3, 0, we're going to have x minus 3. If one of them is negative 6, 0, we're going to have x plus 6. Then we're going to have x minus 2. And then finally, we're going to have x plus 4. So we're almost done here. All we need to now do is find this a value. So once again, f of x is the same thing as y. And over here, we're going to go ahead now, and everywhere we see an x, we're going to replace it with 1 in the equation. And everywhere we see a y, we're going to replace it with 25. So this y becomes 25. We still have an a there. We're going to say 1 minus 3. We're going to say 1 plus 6. 1 minus 2, and 1 plus 4. So once again, we're just replacing every x and y with either 1 or 25, depending on what it is. Let's go and simplify a little further here. We get 25 equals a. 1 minus 3 is negative 2. 1 plus 6 is 7. 1 minus 2 is negative 1. And then finally, 1 plus 4 would be 5. If we multiply all 4 of these parentheses together, negative 2 times negative 1 is a 2. 2 times 5 is 10. And then finally times 7 is 70. So we get 25 equals 70a. And then if we go ahead and divide both sides by 70, we're going to get this. And I can divide 25 and 70 both by 5. So if I divide 25 by 5, I get 5. And if I divide 70 by 5, I get 14. So in reduced form, a is going to be 5 over 14. And so finally, what is our equation? Well, it's f of x equals 5 over 14. That's going to be our a value. And then we're going to go ahead and put in our 3 factors to put this into factored form. So x minus 3, x plus 6, x minus 2, and then finally x plus 4. And there you have it. You now have a 4th degree polynomial that will go through this unique point, 1, 25. Our a value is 5 over 14, and these are our 4 factors. Thanks for watching the video. Hope you got a lot out of it, and hope to see you again soon on another video. Thanks for watching.